So one of the most fundamental ideas with probability is that everything has a probability in between 0 and 1 inclusive. So if you were to put all your answers in this probability section, or if you ever find the probability of something and you put it as a decimal, that decimal should always be in between 0 and 1. 1 represents 100%, 0 represents no chance. So like everything has either no chance of happening or 100% chance of happening or anything in between. But you can't have over 100% chance of something happening or a negative probability. That's not possible. All right, and the definition of probability is the number of ways the event that you're trying to find the probability of can occur divided by the total number of events in your sample space. So for this example, let's say we toss a coin, 2 coins are tossed. So the number of events in our sample space is 4, right? There's 2 ways to flip the first coin and 2 ways to flip the second coin, all right? And if you write them all out, it's tails, 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 heads, heads, tails, or heads, heads. And then if you flip a coin twice, getting 2 heads, there's only one way to do that. One way to get heads on the first flip, one way to get heads on the second flip. 1 times 1 is 1. So the number of ways our event can occur is 1. So our probability of flipping a coin twice and getting heads both times is 1 out of 4, or 0.25. And see, that's in between 1 and 0. Okay, so let's say we roll 2 6-sided die. What is the probability that the total number showing is 7? So if we remember back to the last section, we had that big table with all the ways to roll 2 die. So if you remember the ways to get a 7, well, you can get a 1 and a 6. So like call this die number 1, die number 2. So it could be a 1 and a 6, a 2 and a 5, that adds up to a 7, 3 and a 4, 4 and a 3, 5 and a 2, and 6 and a 1. So 7 is the most common way you can add up 2 die, because there's 1, 2, 3, 4, 5, 6 ways to do it. So that's the number of ways our event can occur. We're going to divide that by the sample space. Okay. Now I don't recommend doing this every time. All right, for this you have to like kind of write out every case, but a lot of times you can use counting principles to find these numbers. So since we're rolling a 6-sided die twice, all right, there's 6 ways the first die could roll and 6 ways the second die could roll. So there's 36 ways you can roll 2 die. So the sample space is 36. So the probability that you roll a 7 would be 1 out of 6. Now what's the probability that you roll 2 die and the sum is not 7? So one way you could do this is to find every possible way you can roll 2 die and not get a 7. And there would be 30 ways to do that. So you could be like, alright, like a 1 and a 1 is a 2, and a 1 and a 2 is a 3, and a 1 and a 4 is a 5. Alright, none of those are 7s, so you add up all those ways. That takes a lot of time. Whenever you see not or at least, sometimes it's easier to find the opposite of that. So like if we're trying to find the probability of not rolling a 7, you could find the probability of rolling a 7, which is 1/6, and use the idea that the probability of rolling a 7 plus the probability of not rolling a 7 is 100%. If you roll 2 die, there is 100% chance the 2 numbers on the die either add up to 7 or they don't. So what we're going to use is what's called the complement principle. Is to find the probability of what we're looking for, take the opposite of what we're looking for and subtract it from 1, or 100%. So if the probability of rolling a 7 is 1/6, the probability of not rolling a 7 is 5/6. Sort of like if I said, oh, there's a 1/6 chance it rains today, well, there's a 5/6 chance it doesn't, because there's a 100% chance one of those 2 things is going to happen.